Hello and welcome to this CATIA Prismatic Machining instructional video. In this video we are going to move into how do we program hole operations. So we've completed all the machining on the second setup, all of the facing operations and mostly a lot of milling operations to generate the design that you can see here to the transparent stock. So now we want to go ahead and machine the holes that are present. Let's just hide the stock temporarily so we can look a little bit more closely at what needs to be done. There are these 6 holes on this outer flange that need to be machined. These are true holes. And then there are these 4 holes on this top surface here that are blind holes. You can see if you look closely into the bottom that there's this conical tip at the end of these holes. There's also a counterbore present. It's a good idea to have a drawing, of course, of your part, and you should always have one because the drawing will have a lot more information about what exactly is going on with holes in particular. In this case here, the CAD model may have additional information for us to pay attention to. So let's go into the CAD model for the part. Let's go into the body. And then if we highlight one of these holes, we can see quite clearly from the icon for the hole that there is also a thread present. So if we double click on this hole here, so now we're in the part design workbench, and then double click one more time, we can see that there is a thread speck on the hole. Okay, so let's jump back into the PPR tree. So you just saw me jumping from one workbench into another. So it is possible to work in part design within the context of the PPR tree. But let's go back over to our setup 2, double click on setup 2. So we're now back in the prismatic machining workbench. So if we think about the operations needed now to machine these holes, we of course need to do some center drilling. So there's center drilling of these 6 holes, center drilling of these top 4 holes. There's true drilling. And then there is blind drilling of these holes, counterbore, and then tapping to put the threads on. So let's take a minute to look at the sizes of these holes that we need to create before we go further. So using the measure tool, I'm going to just measure the radius of this hole. So this requires, radius is 0.25, so a 1/2 inch drill is needed for those, twist drill. And then if we look at these holes up here, tells me the radius is 0.211. So this would tell me that this is probably a 27/64 drill. When we were looking at the tread spec, I noticed that it was a 1/2 UNC, so it's a 1/2 inch threaded hole. And typically the drill that one uses to machine that is a 27/64 drill, which has this radius. And then for the counterbore, we see that the counterbore has a radius of 0.375. So that would be a 3/4 inch end mill would be used to create this this counterbore. So with that information, we can now go ahead and start our planning or our programming. The first thing, of course, that you do for holes is center drill. So we have these 6 holes down here on the bottom and these 4 on the top that we're going to do center drilling for. So let's go ahead and do that. So I'm going to go back up to my setup. We're going to insert those holes after the last pocketing operation. So let's go into our hole list. So if you click on that little black triangle, you can see all the various hole operations that are available. Thankfully, we don't have to use a lot of these. We're going to go with spot drilling. And this here is the dialog for spot drilling. So again, everything is laid out the same as it's laid out for the other types of operations. We start off with the definition of the geometry. So for a spot drilling operation, we need to identify the face that the spot drilling or center drilling operation is going to be machined into. So let's click on this line here, this purple pink line, and then let's pick this face here. Let's do these holes on the outside first, the lower holes on the flange, and then let's hit OK. So that indicates where the tool is first going to hit material. And then this little red triangle here, or partial triangle is used to indicate the locations of the holes that we want to center drill. So if we click on that, there is what's called a pattern selection window. If you hold on your control key and the middle mouse button with the mouse in this window and slide up and down, you can increase the size so you can actually see what's present. So one of the things about hole operations is that if you have created your holes using patterns within the part design workbench, you can actually reselect or select those patterns and use those to help specify the location. So that's really helpful if you have a lot of holes. You don't have to go through and pick every single hole. But you can do that if you want to. If I wanted to, for example, I could, let me just show you, I could click on this hole here and you could see that the hole has been added and numbered. And I can go around and add holes manually one by one. But I'm going to just remove this. So right click, I'm going to remove the current position, right click. So it is possible to do them individually, but a faster way is to use this pattern selection tool. I'm going to expand out the part, and then what you see under there are any patterns that are present in the part. So in this part we have a pattern that was used to create these 6 holes. So I'm going to click on that, and you can see that in one swoop CATIA has selected all of the holes that are in that pattern to be center drilled, and then it's numbered these 1, 2, 3, 4. So it's also created kind of a, actually this is, one is over here, 1, 2, 3, 4, 5, 6. So it's actually created numbered, and it's actually created a sequencing of the holes in that pattern. Okay, so let's hit close and then double click or in the background. And what we have is our dialog window reappears, and we have now green for both the entry surface and the hole. We also have to set the depth of the hole because for a center drilling operation there's no final surface on the part, of course, as there is for either through a blind hole. So we have to specify the depth that we want to go with the center drilling operation to with this value here. So double click on this, and we're going to go down into the surface 100 thou. So we're going to be using a number 4 center drill. Its diameter is about 1/8 of an inch. So this is a fair enough depth. I said OK. So that's our geometry, and then we move to the right, just as we do with the other operations. Let's look at the tool. So CATIA has selected a tool for us from our tooling list. So it went through the tooling list and it looked at the tools that are present, and it found a tool. It probably picked the latest or last center drill in the tree, in the resource list, sorry, and it specified that here. So we now have a correctly selected tool. This is actually the one that I would have picked, the number 4 center drill, for creating those holes. And with the tool number, of course, we want to make sure we select a tool number that works. We're going to change this to 3. So our center drill is going to be T3. And we don't really need to do much more other than that. Again, if you go over to the More button, you can see that a lot of more information has been defined for the tool. So these are the geometry which match these labels. And then there's the technology, and then the feeds and speeds probably being the most important. These are already set for the tool. Okay, so that's the tool. If you go over to the 4 tab, this is our speeds and feeds. So again, here we have information that's copied in directly from the cutting tools. So we're going to be feeding at 10 inches per minute into the material, and we're going to be turning the tool at 6,000 RPM. For our approach, for center drilling, 12 inches per minute. We've been using 15 for our approaches for facing, for milling and facing. So let's just do that. This plunge approach is not relevant for center drilling, so you can ignore this. And then we've been using 60 inches per minute to retract. So we'll use these two here. And again, everything else remains the same. If you do want to change your machining feed, your feed rate, of course, you can deselect and override the value from the tool. But we'll just stick with what's in the tool for now. So that's our speeds and feeds, and let's go over to our approaches and retracts. And you can see for drilling or hole operations, the set that you have is a lot smaller than the ones we've seen for milling, for example. So we have our initial approach, our initial retract, and then there's the linking approach and linking retract. So let's go ahead and activate our initial approach and our final retract. So our initial approach is how does the tool approach and enter material on the first hole. And in this case, what we're going to do is we're going to use, let's just start off using an axial motion. So we have an axial motion here, and let's use 100 thousandths as our axial motion, or axial approach distance. And then for the retract, let's do the same thing. Actually, I got them mixed up. I did the retract first. No problem. Let's just set the approach to 100 thousandths. And then the linking now controls how the tool links from one hole to the next. And so the linking approach is what happens as the tool moves from hole 1 and approaches hole 2. That's the linking between those two holes. And then the retract is what the tool would do as it lifts from hole 2 and moves over to hole 3. So the final retract, of course, is going to be what happens on hole 6. What does the tool do there? So let's set the linking, retract, and approach to. And again, we're just going to set these to start off with using just simple axial moves, just to kind of get a feel for what's going on. So those are main sets of approaches, retracts. Let's go over now, double back to our first tab, and this defines our machining strategy. So the picture here kind of explains what some of these things are. So there's an approach or clearance move, which happens as the tool positions before it starts to move into the hole. So this is sort of an approach that controls the approach move in addition to what's set for the approaches and retracts. It's set now to 1 millimeter or 0.039 inches. Let's round it up to 50 thousandths. The depth mode is how do we measure how deep the tip of the tool goes. So you can go by tip or you can go by diameter. So we're going to go by tip. So it means that we're going in 100 thousandths as we specified in the second tab. Dwell mode determines whether or not you want to dwell the tool at the final depth. We don't want to do that for center drilling because there's no benefit to doing that. So we're going to do none. Plunge mode, we're going to leave it as none too. And then the rest of this information is not relevant either. So there's very little information for center drilling that one needs to specify. It's really the approach clearance. So this is a plane at which the tool will stop before it enters into the machining of the center drilled hole. Okay, let's go ahead and generate our tool paths. And let's go ahead and rewind. Let's go ahead and go plane by plane. I'm sorry, not plane by plane, point by point. And let's step through. So here's our move from the tool change, this red move. This is a rapid move. So the tool is stopping at that 100 thousandths axial distance that we set. The tool is then moving downwards until it's 50 thousandths above the top of the hole. And again, that 50 thousandths is the approach that we set in the tool path strategy. and then the tool is going to go into its feed motion. So this is where it's actually cutting along that green to depth. Then it's going to retract, and again it's going to retract to a distance 100 thousandths, and then it's going to reposition over to the next hole, approach, stop 50 thousandths, feed in, retract, and then move over to the next hole, and so on. So it should be immediately clear to you that there are some issues going on here. And they would become clear to you if you were to go to your material removal. So continuous replay, if we go back to our continuous replay of toolpad and go to full video. And this unfortunately takes a little bit of time now because we are running through. I'll show you a way to speed things up in a second. So notice what's happening with the center drilling operation. The tool repositions from here to here, and in the repositioning move from here to here, the cutter actually clips the edge of the part, and then it runs right through the part, as you can see here, clips the part again, and so on. So we have an issue, of course, where we're not lifting the tool high enough that we have to fix. So there are a couple of ways we can fix this. Let's go to our fifth tab again. One way to fix it universally for all holes is to set our clearance move. So right now the clearance move is deactivated. And what the clearance move, if we set this, will do is it will force the tool between every retract and approach up to whatever option we set here, whatever mode we set here. Right now it's set to the safety plane. This is the global safety plane that we set when we set up the setup. So let's go ahead and activate the clearance and see what that does for us. And let's regenerate the tool paths. So notice the big difference here with the rapid moves, that instead of the rapid moves happening down here, because we've activated the global clearance, the tool is rapiding up to that global clearance plane before it repositions to the next hole and so on. So this may not be the most efficient way of doing things, because maybe you could keep the tool closer here because you don't have, at least moving between hole 1, 2, and 3, you could keep the tool closer. Then of course you do have to lift it up to get through this region. But of course, you know, that means actual additional programming, maybe dividing the operation up into 2 sub-operations to make that happen. But in this case here, we're actually clearing all the various structures by enforcing that clearance move. Another way we could possibly avoid those collisions is to go back to, instead of setting the clearance, let's deactivate this. We could actually go to the, redesign our approaches. So instead of having an approach that's 0.1, we can, of course, do an approach from a plane and set that plane to be this surface here, so that the tool is always approaching from a surface that's high enough. Now, the disadvantage of doing it that way, of course, is if we were to, sorry, let me reactivate the clearance. Generate the tool paths. The disadvantage of doing it that way, of course, is that if I were to select the same plane here and offset it upwards that I have set as the global plane, it means that my approach would be starting from all the way up here. So this would be yellow all the way from here down to there. And of course, yellow is our approach feed rate, which we've set to 15 inches per minute, versus the rapid rate, which is where it is now, which is a lot faster. So again, there are ways to do it with the initial approach, final retract, the linking approach, linking retract to avoid the collision, but you may find that that's not as efficient because of the slower slower approach feed rate and slower retract feed rate versus the rapid approach and the rapid rates that are shown here. So let's hit OK here, and we can see now in our process list we have our tool change for the center drill, and now we have the spot drilling operation present in the tree. Okay, we now need to go ahead and also do the center drilling for these 4 holes. So let's go ahead quickly and do that. And again, as we've done before, we can quickly copy and paste operations if we're not going to change too much other than the geometry. So let's go ahead and copy and paste. This might save us a little bit of time. And let's go into this operation here, and what we want to do is go to the second tab, and we want to go ahead and right-click and remove the entry surface, right-click and remove all positions. And now we want to go ahead and reselect these. So let's go ahead and reselect this surface as our top surface. Hit OK. And then we want to go ahead and select the actual hole location. Now in this case there isn't a pattern present, so we can go ahead and individually select the holes that we want to machine. And then let's hit close here and double click in the background. So we now have the holes reselected. We shouldn't have to change anything else as far as the tool goes, the speeds and feeds, the approaches. As far as the approaches go, we're using an axial approach, so we didn't use a plane, we didn't select the plane, so that there shouldn't be any need to reselect anything. Same thing is true of the retract and the linking, retract and linking approach. The clearance move, let's just deactivate that to start off with. And let's go ahead and generate our toolpaths. So we see here that we have the tool rapiding here from the end of the previous spot drilling operation, the last hole, hole 6 of the previous, rapiding over here and then going into the approach, machining, retracting, repositioning, and repeating that for each of the 4 holes. So let's hit OK here. One of the things one noticed was that we were moving from this hole here and to this hole and starting here. It probably would have been more efficient, since we're closest, this hole is closest to where we ended the previous spot drilling pattern, to start here and then maybe work our way around. If you ever want to change where the whole sequence starts, what one would do is move the mouse over this vertical arrow, which indicates the axes, and then slide down here on the menu to set a start. So what this has done now is it has made this the start hole 1, this is 2, this is 3, and this is 4. So if we regenerate the toolpaths, we can see that there is a lot less motion here. The tool moves from the end of the retract here on hole 6 to the start, and then it jumps around. Now as far as these retracts and approaches go, unlike the lower hole center drilling pattern, there's no obstruction for these to run into, so it may not be necessary in this case to set the clearance move. It looks like it's pretty much doing that correctly as is. Okay, so with that, we're going to go ahead and end here. In the next video, we're going to look at how do we go about adding, of course, the next operation, which is the drilling operation for these 10 holes.